Welcome back. This is All This Math, and this is Professor Parker. And for this video, we're going to talk about simplifying radicals. All right. I got two examples up here. The first one says the square root of 45. The second one says the square root of 75. Now, a radical. What's a radical? This is a radical symbol, right? And because there's no number written in here where the index would go, the number that's written in here, we call that the index. When there's no number written there, it's like what's understood don't need to be said. When there's no number in there, we know that's a 2. So this radical represents the square root or the second root of 45. What does that mean? That means we're looking for the number that can be multiplied by itself to equal 45. And the number written inside the radical sign, we call that a radicand. Radicand. All right, so 45 is the radicand. The number that would normally be written in here, unless it's a 2, we call that the index. All right, and this symbol is called the radical sign. It looks kind of like a long division symbol, right? Now, what we're looking for is the square root of 45. Now, when we simplify radicals, it's like this, right? The first thing you want to do is you want to test the radicand out. You want to say, okay, it's 45. Ask yourself this question. Is 45 a perfect square? Now, everybody watching this video needs to know what a perfect square is. What's the definition of a perfect square? Perfect square is like this. If there's a number, a whole number, right, that can be multiplied by itself and result in that number, then that means that number is a perfect square. Now, I'm going to say it again. If there is a number, a whole number that can be multiplied by itself and equal that number, then that means that number is this number right here. Not the number that's getting multiplied. This number right here is a perfect square. Now, I know 9 is a perfect square because 3 times itself equals 9. 16 is a perfect square because 4, which is also a whole number, just like 3 is, times itself equals 16. 100 is a perfect square because 10, which is a whole number, times itself equals 100. It ain't no number, it ain't no whole number that you can multiply by itself to equal 45. It's a decimal that you can multiply by itself to equal 45, but ain't no whole number. So that means 45 is not a perfect square. When you simplify radicals, that's the first thing you need to think about. Is this a perfect square? Whether it's a number or a variable, is it a perfect square or not? All right. Now, in the event that it's not a perfect square, what you want to do is you want to look for a factor of the number, the radicand, that is a perfect square. That's why you got to, have those elementary school math skills tight. You got to know what a factor is, and you got to know the factors of numbers. All right. Now, if you know your multiplication table, you know your multiplication facts by heart, this should be easy to do. Right. Now, what I want to do is I want to break 45 down or decompose 45 into two of its factors that multiply together to make 45. Right. I'm going to break 45 down into two numbers. Now, I could, what are the different ways to break 45 down? 45 times 1. But we're not going to use that because that's not going to change nothing. We could say 9 times 5, because 9 times 5 equals 45. We could say 15 times 3, because 15 times 3 equals 45. What else can I do? Now, I only want to deal with whole numbers. I don't want to deal with no fractions, no decimals, none of that. I only want to deal with whole numbers. All right. So what I'm going to do is I'm going to use 9 times 5. Why? Always ask the question why. Whenever you're in any math class or you studying math, always ask the question why. Why? Why are we doing that? Why are we doing it? For what? Why am I breaking it down into 9 times 5 when I could break it down into 45 times 1, or I could have broken it down into 15 times 3? Why am I not doing 15 times 3? Why am I not doing 45 times 1? Because I need a perfect square. I need one of them factors to be a perfect square. That's why. Now, somebody might say, oh, what about 1? 1 is a perfect square. You're right, it is. But if I break it down into 45 times 1, then I take the square root of 1. The 45 still in the radical sign. Ain't nothing changed. So that ain't going to help me. That's why I break the 45 down into 9 times 5. So it's going to look like this. This is equal to the square root of 9 times 5. All right. Now, this is how we simplify radicals. So if the radicand is not a perfect square from the root, then that means we got to break this number down. Now, if we can't break it down, then you can't simplify it. Meaning, if the radicand does not have a factor that is a perfect square, then we can't simplify it. We just got to leave it as is. So now what do? Now that I got a 9 times, now this 9 is a perfect square. So what happens when I have a perfect square inside of a square root symbol or inside of the second root symbol. You take the square root, you follow the instructions. This is a set of instructions. All right. So that 9 can come out the house. I think of this radical sign as a house, right? This 9 is perfect, right? So it comes out. When it comes out, it turns into a 3. Why does it turn into a 3? Again, ask why. Always ask why, right? Always ask why. This society tries to obstruct and discourage people from asking why. They just want people to go with the flow. Nah, you got a brain. Use your brain. Start asking why. Don't just go with the flow. Ask why. Math helps to train you to start asking why, and then also to get the answer to the question why. Now, because the square root of 9 is 3, when it come out, it's not still going to be a 9. Why would it still be a 9? If I took the square root of it, that's the only reason it came out. When it comes out as a 3 because the square root of 9 is 3, because 3 times 3 equals 9. Now, what are we going to do with the 5? We ain't going to do nothing with the 5. You know why? Because I can't break 5 down. 5 is a prime number. Again, elementary school math. You got to know the elementary school math. You got to know what a prime number is. If you know what a prime number is, you're going to be cool. You know what a composite number is, you're going to be cool. If you know your factors, if you know your multiplication times tables, your multiplication tables, your multiplication facts, you're going to be cool, right? Now, equal sign, the 3 is outside now, times the square root of 5. The 5 can't come out. Ask yourself, when you're doing these types of problems, you need to be asking yourself, what number can come out? What number can't? What number can come out? What number can't? What variable can come out? What variable can't? We ain't doing no examples with variables right now. We're going to do some other videos on that. And I also already got some videos uploaded to the channel that got variables in them, right? So the 9 can come out because it is a perfect square. The 5 can't come out because it ain't a perfect square. The 5 is a prime number, and there's no whole number. How do I know it's not a perfect square? There's no whole number that I can multiply by itself to equal 5. In the real number system, it doesn't exist. Only way I can multiply two numbers that get 5 is if I do 5 times 1. Those are two different numbers. That's why the 5 can't come out. That's why the 5's still in the house. The 9 came out and turned into a 3. That's the final answer. So square root of 45 is equal to 3 root 5. We call that 3 root 5. 3 root 5, or 3 times the square root of 5. There's no number written here. That means it's an invisible 2. Let's go to example 2, square root of 75. First question, is 75 a perfect square? Meaning, is there a whole number that you can multiply by itself to equal 75? No. You got to know your multiplication facts to know that. You should actually memorize all the perfect squares from 1 times 1 or 1 up to 625 at minimum. I had to do that back in 7th grade, Miss Rosinski's class, Roland Park in Baltimore. I never forgot those numbers. Well, I ain't gonna front. Sometimes I do be forgetting some of them, but once I became a math teacher 20 years ago, I had to rememorize them. Because after 7th grade, I would forget them from time to time. But I know them. You know what I mean? But you know how math is. A lot of stuff in math, if you don't use it, you lose it. You know? So anyway, 75 is not a perfect square. 81 is a perfect square, and that's greater than 75 because 9 times 9 is 81. 64 is a perfect square because that's 8 times 8. That's less than 75. 75 is in between 64 and 81. So it's impossible for 75 to be a perfect square. It's impossible because it ain't no number. There's no whole number between 8 and 9. There's no whole number between 8 and 9. Think about that. There's no whole number between 8 and 9. So therefore, 64 is less than 75. 81 is greater than 75. So there's no way that 75 could be a perfect square. All right. Now, so what we're going to do, we're going to try to break 75 down. Ask yourself, does 75 have a factor that is a perfect square? Does it? How can we factor 75? Or what numbers can be multiplied to make 75? Well, 75 times 1. We know that's not going to help us though. What about 15 times 5? 15 times 5 is 75. But why would I do that? Ain't neither of them numbers perfect squares. So that's not going to help me neither. What about 25 times 3? Hold up. 25. 25 is a perfect square, right? So I'm about to break this down into 25 times 3. And then what do I do with that 25? That 25 is a perfect square. That's perfect. He coming out. 25 is coming out the house and turn into a 5. Why does it turn into a 5? I always ask why. Why does it turn into a 5? Because the square root of 25 is 5. The 3 can't come out. The 3 got to stay in there. 3 ain't going nowhere. You got to chill. Just like the 5 had to chill. Stay in the house. You can't come outside. Right? The 5 be outside. The 3 in the house. Right? The 5 belong to the streets. 5 be outside. The 3 be in the house chilling. So 5 root 3, right? That's the answer. So the square root of 75 is equal to 5 root 3. Now, the steps that I gave you, you can apply in any problem, right? Now, your job is to go practice. I showed you how to do it. Now you got to go practice. Square root of 45. First, ask yourself, is the radicand a perfect square? If it is, just take the square root and you're done. If it's not, and since you're simplifying radicals, in most of your examples, the radicand is not going to be a perfect square, right? Because they're testing you on a different skill here when you got to simplify radicals. Then you got to break the radicand down into 2 factors where one of them got to be a perfect square. One of them got to be a perfect square. Break it down into 2 factors where one of them got to be a perfect square. That's why I broke 45 down into 9 times 5. Why? Because 9 is a perfect square. One of them is a perfect square. Now, dig this. Let me throw this out there. What's going to happen if sometimes a number, a radicand, might have 2 different factors that are both perfect squares? What I suggest you do in that situation is use the bigger one. Use the bigger one. That kind of is similar to like when you got to add or subtract fractions and you're trying to find a common denominator, right? Use the no. I'm thinking of greatest common factors. When you are trying to reduce a fraction or simplify a fraction, and you want to find the greatest common factor to use with that, use the greatest common factor, not just a common factor. It's a similar situation here. All right. 75, break that down into 25 times 3. 25 is a perfect square. 3 is not. That's cool. 25 comes out, turns into a 5. You're left with 5 root 3. All right. And that's how you simplify radicals. All right. So like I said, go get some practice. Practice this. Oh, by the way, shout out to Frantz Fanon, scholar, psychiatrist, Pan-Africanist, revolutionary. Learn about that brother. Learn about the books he wrote and the work he did for the people. All right. Practice simplifying radicals. I'll see you on the next video. Peace.